Hello Flight Simmers and welcome back to Alpha Hotel Flight Simulator Training. In this video we're going to take a quick look at using DME or distance measuring equipment. So what is DME? As the name implies, distance measuring equipment is a receiver on your aircraft that gives you your distance from a station, typically in nautical miles and tenths of nautical miles. DME transmitters are typically co-located with certain types of VOR stations. VORs with distance measuring equipment, simply called VOR DMEs, are represented on charts with a hexagonal VOR symbol surrounded by a square. VOR TACAN facilities, or VORTACs, also have DME capability. VORTACs are VORs that are co-located with a military navigation facility called a TACAN that civilian pilots can't use. But the TACANs do produce a DME signal pilot the civilian pilots can use. VORTACs are depicted on charts with a VOR symbol that has shaded bars on three sides of the hexagonal VOR symbol. DME transmitters are also sometimes co-located with transmitters for instrument approaches, such as ILS localizers, LDAs, and SDF facilities. You can tell which facilities are equipped with DME transmitters on an approach chart by looking for a channel in the data box for the facility. This is a TACAN channel, which again is something only military pilots can use, but it alerts civilian users to the fact that the navigation aid has a DME transmitter that they can use. If the data box has a channel, it has DME. If it does not, it is not DME equipped. DME transmitters operate at frequencies between 1050 and 1233 megahertz, but because they're usually co-located with facilities that you can receive with a VOR receiver, all you have to do to utilize DME is dial in the co-located VOR localizer, LDA, or SDF frequency. For example, I am in the Cessna 172 Classic that has a GNS 530 receiver. This receiver has DME incorporated into it, and in order to receive DME, all I have to do is dial the nav radio that's in here into a radio frequency that also has DME. So I'll dial 16.0, that's the frequency for the Pine Bluff VOR, just a couple miles north of the airport. Flip that into the active frequency, and that automatically dials the DME receiver to the frequency it needs to be on to receive that DME. So now I have a DME display down here at the bottom of this receiver. There are also some DME transmitters co-located with NDBs. With these stations, you'll see both an NDB and a VOR frequency for that station on the chart. So you need to dial in the VOR frequency to get the DME and the NDB frequency into your ADF to receive the NDB. An example of this is up in Cape Lisburne, which is up in northern Alaska. They have a NDB DME located near this airport. You can tell it's a NDB from the dotted symbol there, but then it's got the square around it, indicating that there's also a DME transmitter here. So to get the NDB, we dial in 385 into our ADF receiver, and then to get the DME for this station, we need to dial in 108.35 into whatever we're using to receive DME, whether it's a VOR receiver that also has DME, which is most of the aircraft in the stock version of Flight Simulator, or if you've got third-party aircraft, maybe it is a separate NDB, or excuse me, a separate DME receiver. It is of note that you will not get any VOR information when you dial in that frequency. This is only DME. There's no VOR located with this station. Another note is that these are mostly located in Alaska and they are fairly rare. And then another quirk with these type of stations is that the DME, instead of displaying in miles and tenths of miles, will display only in whole miles. And I think that is a quirk of Flight Simulator. I don't think that's actually how they work in the real world. Using DME with other forms of navigation like VORs gives you much more precise location information than using something like a VOR on its own. With a single VOR, you can figure out what radial you're on from that VOR, but you could be anywhere on that radial. You need more information, like a cross radial from another VOR, to determine your exact position. With DME, you can determine your exact location with a quick glance at two instruments, the VOR and the DME readout. DME is also used quite a bit in IFR flying. It can be used in en-route navigation to identify en-route fixes, and it's used with instrument approaches to identify approach fixes. It's important when using DME that you be aware of how it works and its limitations. The range on DME stations is about the same as VOR, so in Flight Sim you can plan on receiving them between 70 to 130 nautical miles away from the station for facilities that are co-located with VORs, depending on your altitude. The transmitters for approach facilities usually have a shorter range, typically between 10 and 20 nautical miles. DME transmissions are line of sight, just like VORs, so if there's terrain between you and the transmitter, it can block the signal. DME receivers also display what we call slant range distance, which is basically the distance directly from the aircraft to the station. This doesn't account for the fact that the aircraft may be further away from the station vertically than it is laterally, and could cause DME distance to be significantly higher than ground, map, or GPS distance if you're close to the station and or at a high altitude. The clearest example of this would be if you're flying directly over the station. We'll say that we're flying over the station at 6,000 feet, which is 1 nautical mile. So if we look at the DME receiver as we pass over the station, it's going to indicate a distance of 1 nautical mile. It's just measuring the distance we are from the station. It doesn't care if it is vertical or horizontal distance, and we are 1 nautical mile away from the station, just vertically rather than horizontally. If we were to plug this same station into a GPS and then pass directly over the station, as we pass over the station, the GPS distance will indicate 0 because if you look on the map, we're right over the VOR and we are 0 nautical miles from that station. A good rule of thumb for this slant range error is that the slant range distance error is going to be negligible if you're at least 1 nautical mile away from the station for every 1,000 feet you are above it. So at those distances and those altitudes, you can consider that distance accurate. So some examples would be if you pass 1,000 feet above the station, as long as you're 1 nautical mile away from the station, that distance is accurate. If you are 6,000 feet above the station, you need to be at least 6 nautical miles away from the station to consider that distance accurate. And if you're flying in a jet, you're at 36,000 feet above the station, then the distance is not going to be accurate if you're within 36 nautical miles of the station. It should also be noted that DME distances listed on approach charts are slant range distances, so no corrections of any kind are needed to be made for those distances. All right, so to give a little demonstration of the distance between GPS or ground or map distance between the DME distance, we are approaching the Pine Bluff VOR right now. I have it loaded up in the GPS and we are in OBS mode so that it won't start tracking to something else as we pass over it. And then I also have Pine Bluff VOR loaded up in my number 1 nav with the DME displaying down here. Remember how we said earlier, as we get within 1,000 feet or 1 mile per 1,000 feet, the distance starts to get off just a little bit. And you can tell already that it's already showing the distance to the VOR being slightly less on the GPS than it is on the DME. And as we get closer and closer to the VOR, you'll see that error magnified to where as we go right over the top of the VOR, it'll show about a mile down here since we're 6,000 feet in the air, and that's about a nautical mile, whereas it's going to show 0 on the GPS. As you can see, as we're getting within about 2 miles of the station, that error is getting bigger. The GPS distance showing quite a bit lower than is the DME distance. And then as we pass right over the top of the station, you'll see this go to 0, and this will stay at about a nautical mile right. You can see as we're passing directly over the station, this is counting down to 0, but again, we're a nautical mile away from the station vertically, so we're passing over the cone of confusion right now, and you can see we got down to just about 0 on the GPS, but we're still at 1 nautical mile on the DME. So that is an example of how slant range distance works. Again, when you're close to the station and high in the air, you're going to get a discrepancy between the two DME readouts. Many aircraft in Flight Simulator are DME equipped, and most of the equipped aircraft in Flight Sim use a combined VOR DME receiver, most of which are also part of the GPS receivers. The first one we'll take a look at here is the Garmin GNS 530. It has a combined VOR DME receiver in the GPS receiver in the 530, and the way you get the DME to pop up is you put a VOR that has DME in the active field. So I'm sitting on the ground here in Pine Bluff. So I'll go ahead and dial up Pine Bluff VOR, which is 116.0, and I put that in there, and I'm within range, so it tells me what VOR I'm listening to, what radial I'm on, and it tells me my DME distance. Now this is not the same distance field as this over here. The one on the top right corner here is going to be my GPS distance. So if I put Pine Bluff VOR as my next fix in the GPS, when I get close to the VOR, this is going to display the ground distance, so I'm over the top of the station, that will go to 0 or pretty close to it, whereas this is still going to show how high I am in the air, basically. So this is going to have that slant range distance on that. The other thing about this receiver is that the stock receiver in Microsoft Flight Simulator will not load DME when you have it on a localizer or a LDA or an SDF facility. I'll put in the localizer for runway 18 here in Pine Bluff, and you'll see rather than populating that field with DME, it just puts the ILS 18. It puts what runway I'm looking at down here. Now, this localizer actually doesn't have DME, but for all localizers, that's what it populates this field with. There is a mod out there that you can get that will correct this and actually allow DME distances to be displayed in here, and it makes a lot of other improvements to the GNS 530, so I highly recommend it. But in the stock model, you cannot get DME displayed down here. So anything with the Garmin G1000 will also have the ability to receive and display DME information. It does have a DME receiver incorporated into the unit for both the NAV1 and the NAV2, so they're both capable of receiving and displaying DME information. We're sitting on runway 22 right at Little Rock right now, and I have the localizer for the ILS to runway 22 right dialed in nav number 1, and I have the VOR, Little Rock VOR, dialed into nav number 2. That's located about 4 miles to the southeast of the field. We have a couple different options for how we display DME on the G1000. The first option is just to display DME, so we'll go to the PFD options, and it's got a DME soft key there, and we hit that, and that pulls up by default the DME display for nav number 1. So it tells us right here that we're in nav number 1, that the frequency we have dialed in there is 10.3, and our DME readout right now is 1.4 nautical miles. I can change what this is displaying between nav 1 and nav 2 by going back to the main menu and then going to the ADF DME soft key, and then scrolling down with the large knob to the DME mode, and then using the small knob to scroll between the two modes. You can see right now I'm in nav 1. It's picking up the localizer, and if I switch it over to nav 2, now I'm receiving the VOR, and it's giving me the DME readout for the number 2 nav. I'll go ahead and put that back in the number 1 nav. We'll go back to, let's see here, we'll clear this out, hitting the ADF DME key, and we'll go back to PFD options. This is the option that you want to use anytime you want to display DME for a approach transmitter, so for a localizer, an LDA, or an SDF. You can't get it to display using the bearing pointer, which is the other method we'll talk about for those transmitters, because it's not able to put a bearing pointer up here for those transmitters since they're directional versus omnidirectional like a VOR. So I'll go ahead and toggle that off. And the second way to display DME is to display the bearing pointer for whatever radio I want to see the DME for. So all I do is go to the bearing 1 soft key here, and then I can click until I get to the nav radio I want to listen to. So now I have nav 2 selected. It's telling me that the station I'm listening to is Little Rock. It also gives me the bearing to the station, and then the DME readout is just above that. And if I have two different radios that I want to see DME from at the same time, I can click bearing pointer number 1 over to the other station that I want to look at and get DME from. Again, it needs to be a non-approach type transmitter in order for me to see DME off of this. but it will display two DMEs at once, so that's kind of nice. So that's how the DME display works on the G1000. DME display and reception is also available in the Garmin G3x panels, although there is an exception to that if you're using the two portrait screen version of the panel, then DME is not available in those for some reason. That's when you have the two vertical displays rather than this horizontal display, which they call this a landscape display here versus the portrait or the vertical ones. The only two aircraft that have that are the Extra 330 and the Pipistrel Virus SW121 that's in the Premium Deluxe Edition. So every other G3X panel does have the ability to display display DME. You do that through the bearing pointers. So let's take a look. We're sitting in the Cub Crafters NX Cub on runway 22 right at Little Rock again. So in order to dial the radios, we'll take a look at that first. We can either hit the menu key down here, or we can go into the split screen mode, which brings up a moving map in addition to the PFD display, and you can click on any of these menu options down here, which will bring up the select page menu. And then we'll go to nav 1 and we'll change out the frequency here. Currently the active frequency is 16.0 and the standby is 11.5. I want 10.3, so that I will key that in to the standby frequency here and then hit transfer to get that in the active. And that's how we change out the radios there. And then I will enter, get back here, and it doesn't matter if we stay in full screen or split screen for the next step. To get the bearing pointers, I want to go click on the compass rose here. That will bring up the PFD options, and the display DME, I just display the bearing pointer for the radio that I want to look at the DME for. So I will click on bearing pointer. The left side is number 1, the right side is number 2. And that will bring up the bearing pointer and the data display on the bottom left-hand side of the HSI. And so by bringing up nav number 1, it tells me it's nav number 1 down here. Then the next line up, it tells me the identifier for the radio I'm displaying. And then above that, it gives me a DME readout. And again, just like the G1000, I can choose to display more than one. So I can bring up nav number 2, which I currently have dialed into the Little Rock VOR at 16.0. And it tells me nav 2, I'm listening to Little Rock, and I am 4.0 DME away from that. And unlike the G1000, I can actually display DME for a localizer using the bearing pointer. And again, these are going to be DME distances down here versus the distance field up at the top is going to be a GPS distance. So that's how the DME display works for the G3X panels. You can also set up a bearing pointers to display DME on the stock G3000 panel that's in the TBM 930. In order to do that, of course, you have to set your comm and nav radios. To do that, you want to go to your screen that's underneath the multifunction display in the middle and press nav comm home and then go to audio and radios, and then you can dial in the frequencies there. So we'll put 10.3 in for, whoops, that was not the right frequency, 10.3 for the localizer in Little Rock, and then 13.9 for the VOR, and then we go back to home, and then we want to go to the PFD home, so we click on this button to the right of PFD here, and then it has two little buttons there that we can use to bring up bearing pointer 1 and bearing pointer 2. You can also do it through the PFD settings, and it also has bearing 1 and bearing 2 there. So I will bring up bearing 1 to show the nav 1 and bearing 2 to show nav number 2. And that brings us up the same display that we have in the stock G1000, or excuse me, in the G3X. You've got nav 1 identifier, and then we've got our DME readout right there. Same thing for nav 2. And again, just like the G3X, the stock G3000 will show will give you a bearing pointer for a localizer type transmitter. The G5000 in the citation longitude works very much the same, except that the PFD control panel is located over to the left of the primary flight display. Some third-party aircraft have a standalone DME receiver, and they don't work exactly correctly, but they will get the job done. We are in the Mooney 20R Ovation by Carenado, and it does have a standalone DME receiver right over here. It has two settings here, remote and frequency. It will not allow you to go over to the third selection over here, and then has an on-off control that just turns the unit on and off. And we have the remote setting here. We'll just dial this into whatever you have set in the nav number 1 radio. So if I put Little Rock VOR in here, sorry, that's going to be 13.9. So I'll dial Little Rock VOR in there, and you can see it automatically displays my distance. These standalone units also have a way to have an area to display your ground speed and the time it will take you to get to the station at the present ground speed. These things are, well, actually the ground speed is only accurate if you're heading directly to or from the station. If you're flying like a DME arc, it's actually going to say 0 because you're not getting any closer or further away from the station. And then, of course, the distance or the time to the station is only going to be accurate if you're flying directly to the station. So again, it only hooks up to nav number 1 if it's in remote. If you put in a frequency, it allows you to dial a frequency independently on the real life unit, but in Carenado's at least, it's not working correctly. You can see when I'm dialing this around, it's actually directly dialing what I have in the active frequency of nav number 1. So that's how these standalone units work in Flight Simulator. Again, there may be some differences. I don't know if there's a more accurate standalone DME receiver available in a different third-party aircraft, but for the Carenado ones, that's how they work. Most of the jets in the game are equipped with DME. I won't go into the details for each jet in this video, but DME is usually available for both nav radios, and the distances can usually be displayed using the bearing pointers for the appropriate nav radio. They'll also usually be displayed when that nav radio is being used as the nav source for the CDI. That concludes this video. Hopefully it's given you some good information on how to use DME equipment in your flight sim flying. As always, if you've enjoyed the content, please make sure to like, subscribe, and ring that notification bell. Thanks for watching, and we'll see you next time.